Hi everyone, we're going to work through an example of using law of sines and or law of cosines to solve a word problem in application. So this one we have golf. A golfer takes 2 putts to get the ball into the hole. The first putt rolls the ball 10.2 feet in the northwest direction, and I do mean perfectly northwest. So let's say we start down here and this is due north and this is due west. So we go exactly northwest. That's going to be straight down the middle of that. 10.2 feet. And then the second putt sends it due north 3.7 feet. So now I have to go up 3.7 feet. And there is the hole. The question is, how far and in what direction should the golfer have aimed the first putt if the ball was going to get in the hole in one stroke? So assuming it's going to go in a perfectly straight line, we're looking for this distance. So this was where the ball started. And that's where we want the ball to end. So if it went in a straight line, how far is that and in what direction? Okay, so I've got 2 sides. I'm looking for the third. Right now I have a little bit of a problem in that I don't really have any angles. But once again, I can get one just by thinking about these directions. If this is due west and this is exactly northwest, this should be a 45-degree angle, which doesn't immediately look all that helpful, but it does mean that if this is also due north, here's another 45. Which means that this angle right in here is 180 minus 45, which is 135 degrees. So now I have one angle. Let's see, I can't use a law of sines because I don't have either of these other angles, and I'm not seeing that those are all that easy to get because we don't exactly know this direction. But I think I could use a law of cosines because, yeah, I think so. So I would want the one that puts d by itself because I have the angle straight across. D isn't normally in it, but we're going to have this guy by itself. So we'll have a d squared equals 10.2 squared plus a 3.7 squared minus 2 times 10.2 times 3.7 times the cosine of 135 degrees. Okay, and then it's okay to just go ahead. You can decide what's easier. You can either do some of that arithmetic, or you can just rewrite all this with the square root, so I know that's what you did, and plug it all into your calculator. I'm not sure which is easier. Here, I'll do a little bit. 20.4 times 3.7 cosine 135 degrees. Okay. So in my calculator, I'm going to do all of that mess. The square root of 10.2 squared plus 13, no, not 13, 3.7 squared minus 20.4 times 3.7 times the cosine of 135 degrees. You want to close the parentheses for the square root, and I get about 13.08. So D is about 13.08 feet. Okay, so that answers part of the question. We now know this. The other part of the question is what direction should the ball be aimed? So it would be really nice to either be able to say how far from north or how far from west. I don't really care which one. That would actually go to here. But one of those 2 angles would be really nice to find, which says to me that I think I want to find this little piece right here. So let's call this little skinny thing angle theta. And I'm thinking at this point we could use a law of sines. So we could say that sine of theta divided by 3.7 is equal to sine of 135 degrees divided by 13.08, which means we're going to multiply by 3.7, and then we're going to take the inverse sine. Okay, so if we want the inverse sine of 3.7 times sine of 135 divided by 13.08, and I get about 11.54 degrees. Okay, so that's this little skinny wedge of an angle right here. So, for example, if I wanted to say how far from north, I would say, okay, let's do 90 minus my 45-degree angle down in the bottom and my 11.54 degree angle that I just found. So 45 minus 11.54 is 33.46. So this right here is 33.46 degrees. So I would say something like, I think there's probably a better way to say this, but I'll try my Maya version. 33.46 degrees west of north, or from north, or however you want to say that. I think you can do north 33.46 degrees west. I think that would be an official way. Oh, there you go. So now you can see it all. I won't be too picky as long as I can really tell. I don't need perfect navigational wording, but I need to be able to tell exactly what direction you're describing. All right, thanks for watching.